Okay, so this is the recording of the Moneyball office hours for Predict 411, and we are in the spring quarter of 2017, and today is April 6th, 2017. So what I'm going to do tonight, guys, is I thought, since I have some of my older sync sessions have been recorded and I've gone through by building SAS programs ad nauseum. I'm guessing a lot of you guys have already watched those sync sessions, or if you haven't, I can show you where they are. They're usually, they're pretty good way of getting started. I thought tonight what I do is use Enterprise Miner and solve the Moneyball problem that way, and I'll take it from beginning to end. I'll create a project, I'll create a model, I'll score some data with this, and I'm going to submit it off to Kaggle. How about that? Does that sound like a great plan for everybody? I'm hearing, sounds good, yes, okay. If anybody has any other things they want me to cover while we're working on this tonight, I'm happy to do that. Just make sure you put it in the chat window. Hey, Randy, I'm going to use you as my human guinea pig, and what I'd like you to do is, I can't see the chat window when I'm sharing my screen. Can you sort of keep an eye on it and interrupt me with questions as they get typed in?
Yes, be happy to.
Perfect. And the reason why I'm picking on you is because I don't hear an echo when you and I talk. So that's that way I can keep other people on mute. Okay. So let me see if I can share my screen. Okay. So Randy, can you see my screen?
Yes.
Oh, somebody was saying, can you give us a sense of what Rsquared should be for the Moneyball and insurance? I'll tell you what, Scott, I don't want to tell you what it should be for Moneyball, but I'll give you, I'll tell you for insurance. Insurance, you're probably getting a R² of about 1% or 2%. Is that what you're getting? Correct. Okay, well, that's probably where you ought to be. And I don't want to tell you what the Moneyball one should be, because then everybody in the class is going to, like, shoot for that, and I don't want that. I want you to figure it out for yourself. But it's not embarrassing, Scott. It's the reality. This is what the real world is. You've been given these sterile, cozy little data sets in school that you get these 95% R², and you're thinking that this is the real world. That's not the case. Insurance data is notoriously bad, and in the real world, you sometimes get an R² of 2-3%, and you're just, you know, happy as a pig in mud, you know, because that's just about as all you're going to get. So, you know, don't feel bad. I deliberately gave you a real data set so you can see what it's like. So I hope it's not embarrassing, because I've never gotten any better than 1.5, 1.7, something like that. And if you get something like 4 or 5%, you made a mistake. That's too good to be true. If it's too good to be true, it is. So, anyways, any other questions, folks? Or if not, I'm going to get started on Moneyball. Okay, silence is assent. That means you guys all agree. Okay, so this version of Enterprise Miner is the one that SAS On Demand for Academics. So this is the same one. In the past, I've showed Enterprise Miner, and I've shown it based upon the one that I have on my laptop, because I was a SAS employee, and you know, I'm also working on some classes for SAS. So I want to create the program with the same version that you guys have access to, so there's no confusion at all. How about that? So when you bring this up, I'm hoping you guys can get to this screen. If you can't get to this screen, it means you haven't set up Enterprise Miner. And if you do set it up, it's not that hard to do. If you can get it up and running, you get 10 points. Take a screenshot and send it to me. So that's, and you know, I've got a lot of students having it up and running, so I've got to believe that this is not that difficult. I think that some students who have Macs or use the virtual machine may not be able to use Enterprise Miner or have trouble with it. I can't help you with that, okay? I know nothing about Macs, so I'm just saying if you're using Windows, I can maybe help you, but otherwise you're on your own, because once you move away from Windows, it's not an area of my expertise. But maybe Brian or Raymond, our TAs, could help. If not, give me a call and let's see if we can find someone who can help you. Okay. So this is what you get, Enterprise Miner. The first thing you're going to want to do is create a new project. So we're going to do that. And first thing we're going to hit is next. And this is being recorded, so don't have to worry about taking notes. I'm going to post this a little bit later. Now give it a name or something. So I don't know. I always like to start my Enterprise Miner project names with a little lower x, just so I know that they're EM projects. And we'll call this, I don't know, Moneyball, I don't know, 2017-04-06. So that's today. So that's what we're going to call that. So you hit next. And we wait a minute. This might take a little bit because we're got Blue Jeans running and other things. Sometimes it slows things down a little. Okay, we hit next. And here we go. Almost. Okay, so this is now Enterprise Miner. Now the first thing that we're going to do, folks, is we have to set up our library and tell Enterprise Miner where the data is. And we're going to do that exactly the same way as you do it when you're using the SAS Studios. So if you come over here, I have SAS Studio open, and I've already got my commands, or my command here to set up my path, okay? You can hard code this if you want to, but this is what I do. Is I usually use macro variables. So I'll post this code later on, but this is also the exact same code that you use to set up the libraries. If you download any of my old code, this will be the same code for that where you set up the libraries. So I'm going to copy that. So I'm going to copy this. I could type it in by hand, but copying and pasting is so much easier. Okay, we're back over here to Enterprise Miner. And what you're going to do is you're going to click at the very top up here. So you can click all over the place, but we're going to click at the top. And notice when I click at the top, this part down here becomes visible. And when it becomes visible, I'm going to come down here and it says Project Start Code, and I'm going to hit this little dot, dot, dot. And this will be code that is always going to run every time I open up Enterprise Miner and I open up this project. This code will run. So there it is. I've now got this path has been set up and this lib name and all that. What you're going to have to do, now pay attention if you're falling asleep, because this is important. You're going to have to hit two buttons here. You hit Run Now, so it runs, and then you have to hit OK. The first time you hit run, it'll run. After this, it'll run forever. The reason why you hit OK is so it saves. A lot of people don't hit OK, and then they lose that code, and it's a pain in the neck. Okay, so now we've got this guy. What we're going to want to do is add some data sets. So we're going to come over here, and we're going to highlight this guy, and now I'm going to right-click, and it says Create Data Set. And when I do this, it's going to open up a little wizard. And don't worry about what any of these things mean. Just follow what I'm doing right now. You're going to hit Next, and then Browse. Now, the library that I created was called HW for homework. So, oh, look at that. There it is, homework. So I'm going to hit that, and I'm going to double click on it. And these are the data sets that I have there, Moneyball, Moneyball Test, and Moneyball Test Random. Well, we want this guy right here. So let's click on him and hit OK. And then we're just going to hit Next, Next, Next. Don't worry about any of these options. Next, Next, Next. Just keep going to finish. And voila, we now have the Moneyball data set there. Now, the other thing we're going to do is we're going to hit Diagrams, and you're going to right-click there, and you're going to create a diagram. So we're going to call this one, I don't know, 100 first. Well, let's just call this one predict 411 sync 0 Moneyball. There it is. And we'll hit OK. Because maybe what I'll do is I'll do this again for the logistic regression and maybe for Poisson. Okay, so there we go. At this point, guys, you got everything you need. So what we're going to do is we're going to grab this guy right here, Moneyball, and we're going to drag him onto the screen. And usually I hit Run. I right-click and then I hit Run. I've been using SAS Enterprise Miner for 10 years because I've been using it for 20 years since like the year 2001, but I've been working as a SAS employee. I was doing this since 2005 or 6 or whenever I started at SAS. You learn a few things. I always hit Run here because sometimes it doesn't load unless you hit Run. So I just always do that by habit. Most of the time everything is fine, but it's just a good safety tip. So I just hit Run and the data is going to get loaded in there. If you want, just for fun, you can always right-click on this guy, right-click, hit Edit, and here's all of the variables. And if you highlight them, so just highlight them just like any other thing that you do in Windows, and if you come down here to this Explore button, you can actually see the data. So we can come over here, and you can actually go to this guy and open him up. And you can actually physically see the data if you want. You can see we've got some missing values in here and a lot of other stuff. So that's just if you want to play around with the data. Incidentally, these are interactive graphs. So what does that mean? It means if I start clicking on it, I can highlight this data here, and you can see how that same data is distributed everywhere else. So this is something worth playing around with. And also this blank bar here means I've got missing values that we're going to have to fix. So let's close out of here. And then we're about to get started. The first thing we're going to do is we're going to come over here to this Utility tab. We'll click on that guy, and we're going to look for this guy right here. This is the Metadata tab. And we're going to drag him on the screen. And this is where we're going to tell Enterprise Miner what to do with the variables. So I've connected it, right-click, and I'm going to hit Run, and it's going to load the data into this guy. Now, something that you're going to wonder is that Enterprise Miner is one of these tools where you can usually do a lot of things in a lot of different places. Like what I'm about to show you right now, we can do in about 5 other places in this tool, but only do it in the metadata node. The reason why is because there's so many places you can remove variables from your model or set them to something else, and it's very easy if you have a complicated model for it to get lost, where you're like, where the hell did I set that thing to a rejected guy? And you don't know where it is. If you know that you're only going to do it in a metadata node, then it's easy to find. When you got 50 nodes on the screen and you only got like 3 metadata nodes, you know where to look. So what I'm showing you is a best practice. So we're going to click on this guy, and then we're going to go over here to this side of the screen where it says Train, and you're going to click on this guy. And we see the same exact screen that we saw when we opened up this guy. Well, what I'm about to do here, I could have done in here, but you don't want to do that. You want to do it only in the metadata node because it's going to make life a lot easier for you if you ever have to debug a complicated diagram. I'm trying to give you best practice tips as we go, because then this way, if you ever use this in the real world, I can make your life a lot easier. So the first thing we're going to do is index. If you look at that, that's the number of the team, like team 1, team 2, team 3. You don't want to put that into your predictive model. So if I don't want to put that in my predictive model, SAS thinks that that's an input variable. So he's going to use that, and I don't want him to. So I'm going to come over here, and I'm going to say, no, that's an ID variable. I could also say rejected if I wanted. Like rejected is, he won't use an ID and he won't use a rejected, but there's very little difference between the two for our purposes. But I like to say what it is. It's an ID variable. I see a chat message. Randy, could you read it to me?
Yeah. So Scott asked, can you show us how to use it to predict missing values? Should we use a tree or a regression model?
Oh, well, never use a regression model to fill in missing values. I'm going to show you how to use this to fill in missing values, but you can use regression models. I never like to say never, but regression model, if you wanted to use regression to fill in missing values, you add a level of complexity that is significant, and what you get in return for it is not that much better. So I always ask, is the juice worth the squeeze? You know, am I going to get enough juice out of that lemon to squeeze it? If not, I'm not going to squeeze it. That's usually something people don't usually use regression formulas for filling in missing values. Trees are about as complicated as people will go. So, in fact, Enterprise Miner will not even do regression imputation. It'll fill it in with an average value, or it'll fill it in with a tree. Okay, those are the ones that it will give you, and those are what people use 99% of the time in the world. So I'll show you how to do that. We're going to get to that shortly. Okay, so I see another chat message, or was that the same one?
There was an earlier one from Steve Hall that just said he's on a Mac and he gets Enterprise Miner to work on a Mac.
Great. Then I'm glad that it works for that, because I wasn't sure that it did. I had students in the past that had trouble with that. Okay, so normally at this point, if you look at the rest of these things, SAS thinks they're inputs, and that's the default. Now, I'll give you a best practice as long as we're here. What I like to do is I never take the defaults. I will manually say that this is a target variable, even though SAS already thinks it is. I like to hard code it like that. And then all the rest of these guys, I'm going to put them as inputs. Okay, now why do I do that? The reason why is that SAS takes his best guess as to what kind of variable is it. And what will happen is sometimes I might come over here and get a new data set. Okay, like let's say Moneyball, and I update Moneyball with some new data. And then I bring him in, and I want to drag a new data set on here. And I was going to and get rid of this guy. We're going to pretend this is new data. And if I hook him in, then what happens is SAS defaults, like he says, well, gee, I think that the ID variable is actually a target or something. He guesses wrong. If I'm only using the defaults here, suddenly everything is going to get screwed up, and we don't like that. So if I hard code it, no matter what SAS thinks, I'm setting it to what I want it to be. So that's what I always like to recommend. So that's like a best practice. Now let's do one other thing. Let's open this guy up again. I want to show you one other thing as long as we're here. Okay, over here, SAS lets you decide what type of variable do you have. So right now, again, he thinks these are all intervals. Intervals are just numbers. But and that's the default. But he also gives you the option of it being binary, yes, no, true, false, up, down, 1, 0. It could also, and when we do logistic regression, you're going to get that. It could also be an interval, which is a number. It could be a nominal, which is a class, okay? A class is like red, green, or blue, okay? And then the last type is an ordinal. An ordinal is a class that has an order to it, like letter grades on a report card, A, B, C, D, F, okay? So right now, all we have is interval variables. So let's just go and set these all to intervals. Again, for the same reason. It doesn't hurt to do this, but it's safe, okay? So at this point, we got all these guys as inputs, and voila, they're all intervals, except for this is an ID variable, and SAS will not use this in the model, and this is the target. So we hit OK. Now, what do I do? Well, we can do one of two things. In a real-world situation, I'm going to go over here to sample, and I'm going to grab the data partition, and I'm going to go and decide if I want to create a holdout sample. So right now, SAS has got 40, 30, and 30. He's got 40% of the data is going to be for training purposes, 30% for testing or for validation, and 30% for test. What's the difference between validation and test? Okay, the difference is this. Some of the SAS algorithms will actually build a model on training data, but then when he wants to tweak the model, like let's say you've got a decision tree and he wants to prune it back, he'll prune it back with the validation data set. So data, it's like he tests the model on the validation and then fine-tunes it. And then, of course, test is just holdout sample that we're not going to use for anything. Now, validation data is typically used more in the realm of people who've got a background in machine learning. Pure statisticians don't usually use it. I've played around with this for 10 years when I was with SAS, and I've come to the conclusion it doesn't make a hill of beans worth of difference if you use it or not. You know, it just depends on what you feel comfortable with. For our purposes, I'm going to just set that number to 0, and then I'm going to use 70% to build the model. I could change these to anything I want. They have to add up to 100. Now, here's another neat thing. This is a random number seed right here. And what I will typically do is if me and let's say Steve Hall and Randy and Megan and everybody else on the call, if you guys all set your Enterprise Miner diagram up the exact same thing as I do, we're going to, and we all have the same random number seed, 1, 2, 3, 4, 5, we're going to get the exact same answers. Basically, when he pulls names out of a hat and says this guy's going to be a training data, and this guy's going to be test, et cetera, he'll come up with the exact same training and test. If you change this to something else, like 1, 2, 3, 4, 6, what will happen is it's like shuffling a deck of cards. You will get different guys in your training data and different guys in your test data. I'll show you a really neat trick that I use to validate my models at the end. What I will do is I'll build my model, and I'll see how accurate it is. Then I'll change the random number seed and rerun it again, and then I'll do it a few more times. And if I consistently get similar models with similar accuracy, not the same, but similar, I think I've got a stable model, and I'm happy with that. That's what I do. So let's change this back to 1, 2, 3, 4, 5, so that you guys, if you're running this at home, you'll get the same answers. So I'll just run this guy. Now at this point, we're ready to start building models, guys. So let me just load this data. And we're actually, believe it or not, close to being finished. Okay. Now, what I normally do in a real-world situation is when I want to build a model, the first thing I will always do is I'll build a tree. Why? Because a tree is going to give me a pretty darn good idea as to how accurate the model is. I use that as my benchmark. You're going to find that a decision tree is going to be pretty darn accurate, and it's usually a pretty darn good model. So I like to start with that. So I'm going to come up here and hit Model. I'm going to grab a tree, throw him on the screen. Now, you got to do a regression for sure, but use this guy as a benchmark. Then you're going to come over here to Assess, and you're going to grab this Model Comparison node and drag him on the screen. Okay, and then as long as we got this Model Comparison node, highlight him, come over here, and let's say that we want to find the best model, and we'll use, I don't know, the oops, let me make this a little bigger so I can see it. We're going to use the mean squared error. So we're going to choose the best model using mean squared error, and we want to look at the test data. So we're going to let SAS, we're going to say, look at the test data, and I want you to tell me how good the model is based on mean squared error. Now, right now, we only got one model, so, you know, big deal. But we're going to have a few more in a minute. And so now we're going to hit run. Now, the nice thing I like about trees is they can handle outliers. So if you got some weird answers, the tree can handle it just fine. The other thing that trees are really good at is they can handle missing data. So I don't have to do a thing with this decision tree. I just throw the data in and let God sort it out, and it does a really nice job. So this is what I love about decision trees. And incidentally, let's just take a quick look at our model comparison here. And we wait and wait.
Don, what's the difference between run and update?
Update, the only purpose of update is if you start changing this, like if you mess around with the metadata here and you change something from input to rejected, if you update, then he'll update the metadata. Did that make sense?
Yes, thank you.
Okay, so let me just open this guy up again. And we're going to do a regression in about 1 minute. So what we really care about here is this guy, which is the average squared error. So the average squared error on this guy is 140. So that means, well, that's the average squared. I wonder if we got a root mean squared error. Yeah, root average squared. That's the one we care about, probably. Let's take that guy instead. So the root average squared error is 13, which means that when I predict how many games you're going to win, on the average, the decision tree is going to be wrong by about 14 games. So, you know, you predict, 80 games, and he's going to probably be anywhere from 94 down to 66, but he's going to be sort of in the ballpark. But that's what that means.
There's a couple of questions, Don.
Okay, fire at will.
First one, do you have recommended reading on decision trees? I'm having trouble understanding the results of decision trees.
Well, I can explain them to you right now. There's a lot of stuff on decision trees. I'm trying to think of where the best place to find those things other than Wikipedia or just poking around on the web. I'm trying to find a good source for them to post. But let me explain them to you right now. When you look at a decision tree, this is what it means. I mean, I'll explain how to interpret the tree, okay? Now, this is an Enterprise Miner version, but Angus has good trees. R has accurate trees, but it's hard to interpret them because it gives you if-then-else rules. But this is how you do it. Right now, up here in the very root node, if I don't know anything about you, the average number of wins that a baseball team is going to have in my training data is 80.7. So we'll call it 81 games. So if I don't know anything about you, your average is 81 games. However, let's take a look at your base hits. Now, if I don't know anything about you other than the fact that you had less than 1,403 base hits in a season, so if you didn't hit the ball very many times, the number of wins that you are going to win on average is 73. So in other words, if you didn't hit a lot of baseballs, the number of wins you're going to have is going to go from 80 down to 73. But if you got a lot of hits, so if you hit the ball then suddenly your chances of winning went from 80 to 83. Okay, so then what do? Then we look over here, and then I say, okay, let's look over here. Errors. So I didn't hit the ball very many times, but I made a lot of mistakes. So the ball comes to me, and this is like me in Little League, and the ball would come towards me, and I'd run, because it hurts to get hit by a baseball. And the coach would say, don't be afraid of the ball. It doesn't have teeth. And I would think, yeah, but it's a hard projectile hurtling at me at a high velocity, and that's going to hurt. But, that's why I rode the bench. But okay, anyways. So this guy didn't hit the baseball very often, but he made a lot of mistakes. So the number of wins went from 73 to 56. And then he struck out a lot. But that's kind of interesting because this is now counterintuitive. Because now I got a lot of strikeouts. Well, that should be bad. So what happens here is that this, it seems to be the guys who strike out more get more wins. I don't know why that is, but I probably wouldn't use this. I would probably stop right here and not go any deeper into this tree, because now I'm starting to get counterintuitive results. But basically, the tree is just nothing more than an if-then-else. They're not perfect, but they're pretty good ways. They're good at fixing missing values. They're good at variable selection. They're good at modeling. They're doing a lot of good stuff. So whoever didn't understand trees, do you understand when you look at this tree here, can you understand what it's telling you, or does this make a little more sense to you? I'm hearing silence. Am I still on the line? Randy, can you hear me?
Yeah, he just Scott answered, that makes sense.
Okay, great. So the neat thing about this is, boy, I don't want to run down the rat hole of decision trees, but what the heck, huh? Okay, as long as you're interested, let's go over here with our friend the decision tree. And if you click on interactive here, after the tree has been trained, this is kind of cool. So if you're falling asleep, wake up. This is kind of a neat thing. And this is why you guys should also open up Angus. Angus has got some great decision trees. Theirs are different from SAS. And incidentally, there's no right answer with a tree. I mean, you can get completely different trees, but they're both right. I mean, trees are machine learning, so it depends on where where the algorithm is searching for the data. Regression, if you and I have the exact same data set, we should get the same answer for regression. But decision trees, if you and I have different algorithms, we might have different starting points, different It's like if I give each two guys an oak tree seed. You get one and the other guy gets one, and I grow mine over in Ohio and you grow yours in Minnesota. You're going to grow an oak tree, and it's going to go, okay, that's obviously an oak tree, but your tree and my tree will look different. The branches will look different, etc. But we're both going to have oak trees. So that's the same thing here. Okay, so I've got an interactive decision tree here, and if I come up here and I hit right-click and come down here and hit prune, he deletes everybody. And if I right-click again and hit train, he trains the tree. So I can come over here and hit prune. And I can come over here and hit prune. And prune. And prune. So look, I've got a tree now with 4 levels. Okay? And let's come over here. And remember, I can train, at any point I can train the tree, and at any point I can prune the tree. There's one other thing you can do here. I can also right-click, and I can split the tree. And SAS will give me the 5 best variables. Well, right now he said strikeout was, in his opinion, the best variable, but I didn't like that because it came up with a counterintuitive answer, remember? So if I hit this, people who strike out a lot win more games than people who don't strike out a lot. Well, that doesn't make sense. I don't like that. So I might decide to use, let's see, walks, team walks. So if I walk, if I get a lot of walks, which means that, somebody throws the ball and I don't get a lot of, and I just stand there and he gives me 4 balls, guess what? I get to go to first base for free. Well, I seem to win more games, but if I don't get a lot of walks, I lose more games. Okay, you know what? Makes sense. I like that. I'm allowed to do this with trees. Mathematics is not a suicide pact. You can do, if logic says one thing and the math says something else, go with the logic. Unless there's a reason, like, you're not sure, then do some research. But this doesn't make sense to reward people for striking out. So I would go with this guy. So let's take a look at this. Maybe we'll split this guy. Team stolen bases. Okay. So I have 107. So if I don't steal, if I get a lot of stolen bases, I win more games. If I don't, I lose more games. Okay. Let's try this guy split. Let's do stolen bases just for fun. The stolen bases, if I steal a lot of bases, I win. If I don't, I lose. And let's try the last guy here. Split on pitchers striking out the other guys. That should be a good thing. So if I strike out the other guy a lot, ooh, that's not good. I lose. I don't like that. It doesn't make sense to me, so I'm not going to use it. This is how I build trees, guys. If it doesn't make sense, I don't use it. Doubles, that's a good thing, right? Let's hit that. So if I get a lot of doubles, I lose. I don't like that. Let's try something else. Errors. Those aren't good. If I get a lot of errors, I lose. Okay. If I get not a lot of errors, I win. Okay, good enough for me, gang. We'll go with it. Okay, we're going to leave this tree as is, and I'm going to hit X to get out of here, and he saves it. So that's our decision tree.
And Don, there was another question from Steve.
Okay.
Do you ever start with a random forest instead of a tree?
Oh, we're going to do that next. That's as long as we're at it. SAS will also, before we do that, we'll do gradient boosting. Why? Because gradient boosting is another type of decision tree. It's basically a decision tree, a lot of little decision trees, like with 1 and 2 levels deep, and they're called shrubberies with, a tip of the hat to Monty Python, and Google that. It's a funny reference, so there you go. So I can put gradient boosting in there, and that's sort of a type of random forest, kind of, sort of, maybe, but it's tree-based, which means it can handle missing values, and it can also handle outliers. But then if I want random forest, I come over here, and you look up HPDM. That stands for High Performance Data Mining. Click on that, and the random forest is here somewhere. There it is. So let's throw these guys in there. And now we're going to do a regression in a second. So let's run these guys and see who the best one is. So it's kind of neat. This tool allows you to let a random forest, a decision tree, a gradient boost to fight it out like, a back alley street fight. This is why I call it street brawl analytics, guys. This is, probably everybody thinks that you're kind of, nerdy for liking math, but this is pretty exciting stuff. So Megan, you're pretty quiet. I know that you're on the line tonight. Who do you think is going to win this? I'm hearing silence. Anybody want to opine? Randy, am I still on?
You're still on. Nobody's commenting. I'll say decision tree.
Okay, let's find out. Let's see who the winner is.
Oh, a couple other people have voted for gradient boosting.
Interesting. That's actually not a bad guess, the gradient boosting. But I'll tell you one thing about the gradient boosting is that SAS's gradient boosting is not as good as the one from R. R has got a better, XG boost is better than SAS's, although SAS has got a good one, but XG boost is really good. So if it was XG boost, I'd vote on it. But, you know, here it is, the tree. Let's find out who did the best. Average squared error. Oh, root mean squared error. Okay, 11, 13, and 14. So look, the difference between these guys is not, there's not a dime's worth of difference. This guy gets 11.6. This guy's at 14. That's like 1.5, you know? Or is it 2.5? Yeah, 2.5. That's not too big a difference between these guys. But let's go over here and let's bring in some regression, because this is regression, so we got to use it. I'm going to go over here, and I'm going to use regression. So let's go grab, well, before we do regression, remember we had some missing values, right? So we're going to have to fix those. So let's come over here and hit modify. And right here is where we have our impute. So we're going to grab that guy. And if we just take the defaults, he's going to fill in the missing values with the average, okay? So let's just stick with that one right now. And then let's go over here and let's grab this guy right here, model, and regression. And we're going to call this vanilla regression. And this is a custom decision tree. And this guy here, we have to change this. So don't forget to do this, guys. If you're going to do linear regression, you got to change this from logistic to linear. And by the way, you might want to do like a stepwise or a forward or a backward. I always like stepwise. I'm sorry. I'm a sucker for stepwise regression. And we're going to choose the best one based upon Schwartz-Bayesian criteria. Why? I don't know. It doesn't matter. It'd be kind of a fun thing to try a couple of different ones and see who makes it into the model. So let's see this. And then while we're at it, let's do one more. Let's go over here and do modify, bring this guy down. And now we're going to change this thing so he's going to fill in the missing values to decision tree imputation. Oh, and by the way, let's come down here and where it says indicator variable, let's change that from none to unique and rejected to input. So now he's going to create a flag, because if it's missing, he's going to fix it, and he's going to say, by the way, I fixed that variable. Sometimes the fact that a variable is missing is highly predictive, okay? For example, if you're doing credit and I don't know what your debt to income ratio is, the fact that I don't know is a problem. It means that you don't have a credit history. It means you might have changed your ID and you may be committing fraud. It's kind of like, so the fact that data is missing is highly predictive sometimes. So Enterprise Miner is going to come over here and he's going to fill in these missing values. And then he's also going to create a flag variable. It's kind of like that one episode of Sherlock Holmes. There was a Sherlock Holmes episode where this dog didn't bark. And then the fact that the dog didn't bark meant that the dog, that's missing data, but it meant something because the dog knew the killer. And the reason why the dog knew the killer was because the killer was the owner. So that's a spoiler alert, guys. So if you don't know that's Sherlock Holmes, forget that, okay? But you get the gist. Okay, so I've got this decision tree imputation, and I'm creating some flags. Let's come over here, and let's see, model. Let's do a regression, and this is We'll call this guy tree impute regression. Okay, we have to come over here. We got to change this guy over to, oops, linear regression. And we also have to say we are going to do forward. I don't know, we'll do forward, and we'll do Aikiki's information criteria. So let me just run this real fast because I want to show you what the data looks like now.
There's a question while it's running. Steve asked, not to get off topic, but for gradient boosting in forest, do we need to alter anything like pruning? It sounds too good to be true to drag and drop.
You can drag and drop a lot of this stuff, and the guys in North Carolina set some pretty good defaults. For the most part, when I'm doing anything with gradient boosting or random forests, because they're not easy to deploy those models into production, I probably won't ever actually use it in a model. I use it instead to benchmark the stuff that I can use, like a regression or a tree or a neural network. So I take the defaults, and I very rarely will I monkey around with these things. But if you come over here, like you click on this guy, there's all sorts of different settings for this guy. Now, how do you know what they are? Well, if you click on them, you come down here and you come down here and you click on these things and it tells you what it is. Or you can always come up here to help, hit help, and then you can hit contents, and then you come down here and you'll say models, and then you're going to look for gradient boosting. And then there it is. This is everything you want to know about gradient boosting, all of the options and what they mean. And SAS is not alone in this. Other people, Angus is another one that will have pretty good defaults, okay? Anyways, if you look at this guy right here, you'll notice that we've now got imputed variables for like caught stealing and stolen bases, and he's also got these flag variables. So you can see over here, let's just select both of these guys and pull them up real fast. And we wait a minute. Or not. This doesn't seem to be working, does it? Oh, there they are. So you can see here that the caught stealing, a lot of these guys were missing. And if I highlight them, you can see this is where SAS put them. Some of the missing guys got put in here. Whoops. Some of the missing guys got put here and here and here, et cetera, et cetera. So if I just imputed with the average, they'd all get put at the same value. But he looked at other things. So there we go. So we got this guy. Let's just see who made it into the model, and then we're going to let these guys all fight it out at the end and see who's
There was just one more question. How do you fix outliers in Enterprise Miner?
I can show you that as well. That's a good question. There's a lot of ways to fix them, but I'm trying to think of the easiest way. So right now, what does he have here? He has the fact that if the team's base running value is, well, you know what I'm going to do? Jeez. I'm making this thing complicated. As long as I'm going to show you, I'm going to show you how to do it right. Okay. After an impute node, I traditionally will come over here, grab a metadata node, connect them in there, run. And then we're going to fix the outliers in a minute too. Then I'm going to click on this guy. I'm going to hit train. And wherever I got these flags here, what I like to do is I like to turn these flags from binary. Whenever I stick them into a regression, I usually like to put them into numbers. It just makes interpreting it a lot more easy.
And Scott asked, why not fix the outliers in the first metadata node so it's centralized?
Oh, you should. We haven't even gotten there yet. So let's do this guy first. And let's see. I'm only going to fix that. I'm going to fix them over here. And the reason why I'm going to fix them over here is because I'm going to let the trees and stuff, they can handle outliers, so I don't want to monkey with the data. So I'm going to come over here, and you can do it with code, and there's ways to put code into Enterprise Miner and code it up yourself, but we're not going to do that today because we'll do it the next time we do a sync session. But what I'm going to do here is I'm going to go to Modify, and I'm going to go to Transform Variables. Delete that guy. Let's delete that guy. Okay, so we're going to transform the variables. Now, incidentally, this is driving me nuts because it doesn't look pretty. So we're going to have to make this look a little bit nicer. Now, just because this is an easy tool, I'll give you bonus points for doing it, but I still expect you guys to be doing it with code, okay? There's reasons that people still write code because it's effective, and I don't want you to get into, you may end up in a company that doesn't have Enterprise Miner, okay? So I don't want you to, don't rely only on this tool. You got to learn to do it the hard way. Am I hearing a, okay, Don, we're all over that one. Randy, am I hearing agreements on everybody?
There's a lot of amens, but
okay, that's what I want to hear.
Somebody prefers R still.
Well, okay, R is fine. I love SAS, but has anyone ever heard me say a bad thing about R? Never. You got to learn R. That's why I'm giving you bonus points for it. Okay. Transform variables. We're going to come over here, and there's all sorts of different ways we can transform variables inside of Enterprise Miner. Now, the defaults are over here. And you can do it a couple of different ways. Like what you can do is highlight these guys and hit Explore and see if there's any outliers. Just eyeball it. This is going to be a really funny SAS joke. We're going to run proc eyeball. Okay? So hits allowed. There seems to be some outliers there. Okay, that's one. Team batting home runs, that doesn't seem to have any. Doubles, nah. Anybody else eyeballing any prompt? Strikeouts by pitcher, that has some. Not so much here. Not so much. Triples, a lot of them. Now, I'm just looking for the obvious ones. Caught stealing, that's not a big one. Stolen bases. Hits. Is this a lot of hits, 2,500? Batters hit by pitch. I don't know. Let's just stick with a couple of them. Hits, let's stick with pitching strikeouts and errors. And pitching walks. So these are the ones we want to fix, these guys, these four. They look like they got a lot of outliers. Let's write these down because I'm going to forget them. Fielding errors, pitching hits. That's your pitcher lets the other guy get a base hit. Pitching strikeouts and pitching base on balls. Okay, those are the outliers. Now, how would I fix these things? So pitching errors or fielding errors, I might do like say a log transform. And then the pitcher pitching hits, base on balls, and strikeouts. Let's make them all log transforms. And usually whenever I do something to variables, I always put one of these metadata nodes right after it, just because. And we're almost done, guys. I hope I'm not keeping you too late. It's 10 o'clock. We've only been at this an hour. But
And we do have a few questions now.
okay.
By the way, Rebecca's the only one that laughed at your joke. So
Which one?
About proc eyeball, I think.
Okay. Rebecca, you're going to get some bonus points for that.
John asked, how do we implement model compare in SAS Studio?
You don't.
I think it's
you got to just calculate it yourself.
And then Steve asked, how would you trim the values?
Okay. So trimming, I wonder if trimming is an option. I don't know if it is. Bucket. No, I don't think it gives you that as an option. If you want to trim it in Enterprise Miner, okay, I'm going to show you how to trim it. But now we're going to have to go into code, guys. Okay, let me just open this guy up and I'll show you real fast. When he transforms it, we've now got these log transforms. If we look at them now, they should be a lot more pulled in. But the problem that you run into now is that this is going to be harder to interpret, okay? See, it's going to be harder to interpret this when you're writing up your report. So if you want to trim it, this is how I would do it. So that's how you would do it here. But I'll show you how we're going to trim it. We're not going to use that. We're going to use code. We're going to go old school here, guys. Okay. Let's run this guy to make sure the data gets loaded. Okay. So now what we're going to do is we're going to come over, you highlight the code node, come over here and hit code. And we wait, because it always takes a long time for the code node to open. Okay, this is the window you get. You don't want this window. You want to hit this guy here, the score code. So go here, now go down one and click. Doesn't look any different, but it is. Okay? You want this window that says score code. Now, the variables that we have are, which one did we want to do? Let's just fix one of them. Let's do the fielding errors, this guy. Okay, hit explore. And we're going to say that the fielding errors, if it's ever more than a certain amount, we're going to cap it. Okay, so let's say anything more than 900. How about that? Is that good? I'm not hearing any silence. Silence means you agree. Okay, so what we're going to do is we're going to say if team, F-I-E-L-D, team fielding errors is greater than 900, then voila. So that's it. And now it will not ever be greater than 900. That code will incidentally, when we deploy this thing, that code will be implemented. Now I'm going to show you one other thing as long as we're here. I'm going to take a decision tree and I'm going to drag him off of, this guy is going to go into here, into the decision tree, and then the decision tree is going to go into the regression node. And where's my regression node? And we're going to make this guy a linear regression. Now what's going to happen, tree var select, is this is going to be so cool that if you guys are asleep, wake up for it, because it's really going to be cool. Okay, so now he's right now capping the errors, so the errors will never be greater than a certain point. We're imputing the missing values as the average. Right here, we're building a decision tree. This is just your vanilla tree. Here's our decision, our regression, but we're going to let the decision tree select who we're going to use. And we'll see who the best one is.
And while you're waiting, Scott asks, why use a log transform when it seems like the data is in error? For example, no team has ever won 146 games.
Well, the reason why 146, what happened is I got a data set from that includes teams from 1902. And those guys only played 3 games. So I normalize it up to 162 games. Then guess what? When you normalize a team that only played 7 games and you normalize it up to 162, and these guys played the Girl Scouts and the people in the old age home and whatever, and so they won a whole bunch of games, and then when you normalize it, they have 1,000 home runs, and they win 159 games, et cetera, et cetera. That's why this this data is messy data. So interestingly enough, let's take a look at this decision tree. So you've seen what decision trees can do. I can impute missing values with trees. I can build models with trees. But one other thing that I can do is I can build a model right here. So the decision tree gets this stuff, okay? He gets all the variables, right? However, if you look at the stuff that the tree liked, he built a model and he said, well, I'm going to predict who do I like and what variables do I want to use. So he builds himself a decision tree to predict who's going to win. Okay, so he builds that guy. And if I take and dump him into another node, like a tree, let's put a neural network in just to get really exotic. Let's throw a neural network in here. But anyways, so this guy builds a tree, and if you look at the regression node and you hit edit here, look at all these guys are rejected. Why? Because the tree didn't use them. If the tree likes you, if the tree liked the variables, then they'll stay as inputs. Otherwise, they get rejected. So in other words, the tree can be used for variable selection. That's a neat tool. It's automatic, but I could just open the tree up and look and see what the tree likes. And I can even do this. I can build the tree, and then I could go over here and then do a stepwise selection on it. You know, I don't have to choose. I could do whatever I want. And heck, if you really want to get crazy, dump him into the neural network and let him. He'll select the variables for him. He'll do a stepwise selection, and whatever's left goes into the neural network. So let's do this, and then let's choose a winner and then deploy the model. How about that? Where are we at now? Does anybody have any questions? I mean, does this make sense what I did here, or did I just totally lose everybody at the bakery? Randy, help me out. What are they saying?
No comments yet. Sounds good. Seems like fun.
Oh, this is a lot of fun. And those idiots at SAS paid me for 10 years, and all I did was play with this tool all day, every day for 10 years. Yeah, you learn a few tricks after you do that.
There was a question. Show us how to impute variables with the tree again.
Oh, that's easy. You came over here, and you set the default method to tree. I can show you how to do it manually, but this guy just builds a bunch of decision trees. But I can show you how to do it manually, one tree at a time. But this guy just builds a bunch of decision trees. And what he'll do is he'll say, okay, I don't know what the caught stealings. Well, I'll do one for you after this. So that's how you do it for all the variables en masse. Okay. To do them all, if you have 100 variables and you want to impute all of them with trees, this is the only way to go. I don't think R has something similar. I think it's got some other tools like mice that are pretty good, but this is kind of neat. Let's open this guy up, and let's just see who the winner is. And we wait a little bit. Okay, so the best guy here, we're going to go and look at the root average squared error. That's what I want to go with. So we're going to do them from best to worst. And so the best guy is random forest, neural network, and then the tree imputing the regression. That's the guy we want. So he's number 3. He'll be the one. We have to use a regression for this, so that's the winner. But if you see, he's not too much different in accuracy from the random forest or the neural network. And heck, even the worst guy's not all that bad. And that's really what happens most of the time with this stuff. Okay, so.
And then while you're teeing that up, a question, how do you view the results to use in SAS code?
Good question. What we're going to do is you come up here to assess. Okay? So you click on assess, and then you come over here and you hit score. Now this is the guy we want, right? Because he was the best. So I'm going to connect him over to score, and I'm going to hit run. Now, if you guys are falling asleep, wake up because you're about to see something so cool you can't stand it. When I used to work at Key Bank, writing score code on complicated models would take you 6 months, okay? Then one day, this node shows up. And my boss comes to me and he says, Don, you got 6 months to write me a score program. And I go, what the heck's this? And I drag it on, and all of a sudden, I run it, and guess what comes out? Comes out like this. So I got 6 months, and all of a sudden, look at that. All the score code is written for me. It took me 1 second. So 3 months later, I go back to my boss, and I say, hey, boss, I got you the model in half the time. So that way, he got the model in half the time. I got a 3-month paid vacation. Everybody wins. That was a little joke, everyone.
There's Rebecca a lot of wowing. She said, wow.
Look, it's all written for you. And the neat thing is, remember that code we wrote? If the fielding, blah, 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 there it is. It gets put in there. Okay, now what do we do with it? We do Control A to select it. Control C will copy it. Now, guess what we're going to do? We're going to get out of Enterprise Miner, and we're going to go over to our friend. Uh-oh. I think it logged me out. And we log into SAS Studio. So what we'll do is, now we're going to go over here. And take a look at this. I've got a skeleton program already written. So now we're going to do data out file. Well, let's do it. Let's do it the right way. Macros. I know you don't, this is the same thing, but I like macros. So that's what we're going to use. Set in file, run. And remember all that stuff we copied out of Enterprise Miner? Control V. There it is. How long did that take to do? 3 months. If your boss ever asked you, that took 3 months. Okay? Proc print data equals out file var index target wins p target wins. Run. Okay? So let's run this guy and see what happens. Let's see what we get.
While that's running, Steve asked, do you always prune? Do you select the number of branches or let Enterprise Miner figure it out for imputation?
In a real world situation, I usually always will build the tree by hand because I cannot stand a tree that doesn't make sense, okay? But you know what? These trees are pretty robust and they're not perfect, but you still end up with some pretty good models. So a lot of people will just throw the data in, see what comes out, and they're good to go, and no harm is done, okay? I just am a stickler that my model has to make money and it has to make sense. I'm a stickler for my model making sense. That's why I do it by hand a lot, okay? So anyways, this is how many teams, how many games they won, and this is the predicted values, okay? What I typically will do is I might go and just do this. Let's copy this out. Before I do anything, I might just make sure my answers make sense. Proc means var, data equals out file min max var. So these are my predicted values right here. Run. So let's just run this guy real fast and see what the biggest and the littlest is. So the minimum is minus 19 games, and the most is 135. Do we got any baseball experts in the audience? Anybody who knows a lot about baseball? Who was it that said something on 140 games being not realistic? Who was that?
Scott.
Scott. Okay, Scott, is 135 games realistic? Can you win 135 games most of the time? What's he saying?
Nope. Most won was 116.
Okay, so with that piece of information, I might go over here into my score code and say something like, if greater than 116, then equals 116. Why? Because mathematics is not a suicide pact. If the model says 135 games, but common sense says that's insane, you don't do it. You put a cap on here. This is perfectly reasonable. Now, a pure statistician guy would think that's crazy, okay? But you know what? Common sense. If you went and told your boss 135 wins, he'd fire you, okay? You don't want to lose your job. Okay, let's look at the other one. This guy, is it possible to win negative 19 games in a season? Scott, what do you think?
Nope.
Well, you remember the Cleveland Indians play professional baseball, and they could. I think if any team could do it, it would be the Cleveland Indians. That's a little Cleveland Indian joke, and I'm from Cleveland, so I can make them. So, Scott, what's a realistic number for losing games?
30.
30? Okay. So if it's less than 30, then it equals 30. Okay. Now, remember, if we run this again, we should have it'll have a limit of 30 and 116. See? 30 and 116. Perfect. Okay, we got one more thing we got to do. This guy here is our data set is Moneyball, but we don't want Moneyball. We want Moneyball test. Remember? And then we're going to come down here and we're going to print this guy, and we're going to print only the index, and we're going to print the wins, our predicted wins. So let's do that. Print, run this guy. Okay. Now I think that we could do this. I think I can download this guy and save as there we go. Now if I open this guy up, we don't care about that one. We care about the next page, I think. There it is. So let's grab this data. What the heck? Here we go. Copy. Wait, is there more? Okay, no, that's it. Copy. And let's paste it. Get rid of these guys. There we go. Now what we could do is we have to save this as a CSV file. So there we go. So we'll save as. Okay, so there we go. We now have a CSV file, and we're going to submit this to Kaggle. How many people have already submitted something to the Kaggle competition yet?
While we're waiting, there's a couple comments. So Scott just put in some code to do a proc export data statement that's in the comments here. Says it's easier to use.
Yes.
And then Paul asked.
Go ahead.
Go ahead. So Paul asked, this code will be used on new data that is also normalized. So 116 plus wins could be in that data, right?
115. Yeah, well, if we put new data in there. Did you see? Remember when we were? I gave him new data. I'm not sure I understand the question, but you remember we built the model on Moneyball, and then what I did was I'm now scoring it on Moneyball tests, so it's now got new data.
I think the question was that there could be more than 116 wins in the new data that it's seeing.
Well, that's true, but we've capped it. I don't care what if it was or wasn't. We've decided with expertise in the industry, somebody's an expert on baseball, he says that it's possible for a team to win more than 116 games, but we've decided that it's so unlikely, we're going to cap it at 116. So in our model, there's no way our model will ever make a prediction of more than 116. Even if it happens, we'll be wrong, but you know what? That's going to happen so rarely that it won't matter. Making sense?
Yeah, there's an okay and a thanks. And then Scott and Steve have both submitted data to Kaggle. So.
Okay. Well, what I'm going to do is now I've got a Kaggle competition. I've got it open, and I've already submitted the worst model. So this is somebody else to ask, how do you know if there's data in the model? I will usually test my model versus some benchmarks. Like I'll come up with the worst possible model I can find. Like I'll deliberately make bad predictions on data that I know the answer to. And then random, I'll just roll dice and come up with something. Then I'll do an average one, which is just me always picking 81 games, okay? So that's how I predict to see is there signal or noise. I'll test it against that. So the model that we are about to submit should be better than, at least be better than this guy right here, okay? So let's find out. Make a submission. And now I got to drag and drop it in here. And we'll say this is the sync session from Moneyball, or for Moneyball using Enterprise Miner. Okay, let's find out. Submit. And where did we end up? There we go. So there, I'm downwetting. And some of you guys are still better than me. Look at that. But of course, we don't know how you're going to turn out because right now this is only on 5% of the data. And what I could do is I could come down here and say show private, and you could see how you do for all 100% of the data. But I'm not going to do that because if you saw how you did, that would ruin the fun, wouldn't it? But anyways, so there you go. This is how you do it with Enterprise Miner. Let me go back with Enterprise Miner for 1 second, and I'll show you how to use decision trees to fix missing values manually, as opposed to doing it automatically. You would do it like this. So let's say we want to fix who's somebody. Give me a variable that has missing values, stolen bases. So what I would do is I would come over here, and I would say, whoops. I would come over here and hit train, and I would turn this into an ID variable. We don't care. And then target, I'd get rid of them. Bye-bye. Rejected. And then I would go over here, and I'd say stolen bases. That's my new target. And if you want to try this, you only have to do it for one variable. Don't do it for all. It's going to take you all year, okay? Just try it for one as an exercise, okay? And then I come over here with a decision tree. And you can do it with R. R's got a really nice, R, Angus. Try it with one of them. Just do it. So let's see. So now we're going to predict stolen bases.
And then Paul asks, question about imputing means for missing data. The score code hard-coded the values from the training set, correct?
That is correct. So you can see that most teams steal 124 bases in a year. But if they make a lot of mistakes, they steal less bases. I don't know. I don't know why, but that's the case. If they make a lot of mistakes, if they make a lot of mistakes, they steal more bases. I don't know why, but that's what it is. So I've got a predictive model here that can predict what the stolen bases are. And I could come over here and we could do something like this. Grab the score code. Where's our friend, the score code? Utility and score code. There it is. Run. Oh, I'm sorry, wrong one. That's SAS code. Randy, that's all your fault.
I'll take the hit.
Otherwise, it would be my fault, and we know that that's not the case, right? So we're going to go over here and do score. And there you go. So then we could do something like this. and then we're going to call it a night. But I'll show you how to do this. This is doing it the hard way with SAS. I'm sure you could do it a lot easier. You know what we're going to do? I'm going to make this really easy. I'm going to make my tree only go 2 levels deep. Okay? So this tree is going to be a shallow tree. So I set that thing to 2. Okay, results. You can see the tree is only going to be 2 levels deep. There it is. So you don't make a lot of mistakes, but you get caught stealing a lot, et cetera, et cetera. That's how it works. Okay. Come over here, results. Control A, Control C. And then there it is. So now we would do something like this. If the imputed team base run stolen base is going to equal to.
There's a question if you're in the wrong tab.
No, oh, you're right. Well, actually, for this purpose, I'm in the right tab because I don't want this code to go into scoring code.
Okay.
Okay. I'm just when I use this tab here, it's just like running a SAS program. So this is going to equal to that, and if missing then is going to equal to the predicted one. There you go. Proc means data. See, we're getting really into the weeds here, and I was reluctant to show you this because I've lost like half the class or more. But for some real advanced people, this is cool. Okay. So if this is confusing you guys, then pretend you never saw this. But for hardcore SAS people, this is cool. And hopefully this will work. And voila. So you can see that base running, we had 131 of these guys were missing. Here's the average. Here's the median, the min, and the max. And then for these guys now, if it was missing, I've fixed them using that if-then-else logic. But you can fix it other ways too. I mean, this is real complicated way of doing it. But the nice thing is, if you were to use this guy right here with trees, all this stuff that we just did here was done for you. But if you want, as an exercise, a very educational exercise, build yourself a tree in R or Angus or Weka or something like that, or heck, and do it in SAS. Do something real simple like this. Try it. Just do one by hand one time, and it's very educational. But, you know, I'll give you bonus points anyway you do it, because trees are great. So, anyways, so this is it for the night, guys. I'm going to...
There was one more question. I don't know if you have time or not. There's a question about how would you do variable.
What's the question?
How would you create a variable?
Inside of Enterprise Miner?
Yes.
Okay. That's easy. Go over here to the SAS code. Go into code. And we wait. And we wait some more. Okay. And then we go over here to the score code. And then you might want to do something like let's see. Okay, here, I got one for you. Team batting 1 base is equal to team batting hits minus home runs three base and minus 2 base. How's that sound? So now we've found out how many times a guy's got a base, a single, instead of a... Because I think... Now, I don't know this about this data set. I'm guessing because there are database experts, baseball experts that told me that hits is not just singles, it's every kind of hit. So if you want to know how many times a guy gets a single, you would do this minus the home runs, minus the triples, minus the doubles. So that, and now that variable, if we were to run this, would also be in this score code. And that variable will be usable for all of them. So does that answer your question? Let's just run this thing to completion just to show you.
Yeah, Paul, thanks you.
So in fact, if you look at the code, we've capped this guy at 900, and we've now created a new variable. There it is. Let's open up Blue Jeans real fast. Are we... Aren't you in the wrong tab? Got it. Thanks. Okay. Do we have any other questions? If not, I'm going to stop recording. I don't want to keep this. This thing has been on for 2 hours, and I don't want to bore people. So I'm going to stop recording, but I'll stay on for questions.